Welcome to Frost & Sullivan's Growth Podcast. In today's episode, we examine how advanced thermal management materials are becoming a strategic enabler of electrification, artificial intelligence infrastructure, and next-generation electronics. As power densities continue to rise and device architectures become increasingly compact, thermal management is evolving from an engineering requirement into a critical determinant of system performance, reliability, and efficiency. What developments are shaping this rapidly evolving industry, and where are the biggest opportunities emerging?
Why are advanced thermal management materials becoming a strategic priority? The increasing power density of next-generation electronics, electric vehicles, and digital infrastructure is creating unprecedented thermal challenges. Heat management is no longer simply about preventing component failure. It has become central to enabling higher performance, greater reliability, and increasingly compact system designs. As industries continue to pursue electrification, AI-enabled computing, and advanced digital infrastructure, thermal management materials are becoming essential building blocks for future innovation. How will organizations address the growing thermal requirements of increasingly complex systems?
What technologies are redefining thermal performance? Innovation is accelerating across thermal interface materials, gap fillers, adhesives, and phase change materials designed for high-power applications. At the same time, advances in graphene, boron nitride, ceramic-filled polymers, and hybrid material formulations are improving thermal conductivity and enabling higher levels of performance. The industry is also moving beyond individual materials towards system-level thermal optimization, integrating thermal performance more closely with product design and architecture. Which technologies will become the next benchmark for thermal performance and efficiency?
What challenges are shaping industry evolution? Despite strong growth fundamentals, the industry continues to navigate several challenges. Cost-performance trade-offs remain a key consideration as organizations seek higher-performing materials without compromising commercial viability. Material compatibility, integration complexities, and manufacturing scalability also present important hurdles, particularly as applications become more sophisticated and industry adoption accelerates. These challenges are driving closer collaboration among materials suppliers, original equipment manufacturers, and system integrators to develop application-specific solutions. How can organizations balance innovation, performance, and scalability in the next phase of thermal management development?
How are industry leaders creating competitive differentiation? Competitive differentiation is increasingly being built around three priorities. The first is the development of multifunctional materials that combine thermal management with electrical insulation, electromagnetic interference shielding, and structural performance. The second is expanding beyond material supply into co-design, prototyping, and process integration capabilities that enable deeper collaboration with customers. The third is building scalable and customizable material portfolios that support rapid deployment across multiple industries and applications. What capabilities will separate tomorrow's industry leaders from today's material suppliers?
Where are the biggest growth opportunities emerging? The future of the industry extends far beyond conventional heat dissipation materials. Next-generation material innovation, including ultra-high conductivity materials, hybrid thermal interface materials, and advanced composites, is enabling increasingly demanding applications. Integrated thermal solutions, including liquid cooling interfaces and thermal architecture design, are expanding the industry from material supply toward system-level solutions. At the same time, emerging applications across industrial electrification, renewable energy systems, advanced mobility, and AI infrastructure are creating new demand for specialized thermal management capabilities. Which growth opportunities align most closely with your organization's long-term innovation strategy?
Thanks for joining us on Frost & Sullivan's Growth Podcast. As industries continue to pursue higher performance, greater electrification, and increasingly intelligent infrastructure, advanced thermal management materials will play an essential role in enabling the next generation of technologies and applications. For access to our research, competitive benchmarking, and best practice frameworks, head over to frost.com or email hello@frost.com. We'll be back soon with more conversations exploring the technologies, strategic imperatives, and growth opportunities shaping industries around the world.